Azure Data Factory, often called ADF, is a powerful tool from Microsoft Azure. It lives in the cloud. Think of it as a central hub for all your data integration needs. Many businesses today collect data from lots of different places. This data might be in old databases, new cloud services, or even simple files. ADF helps you bring all this data together. It doesn't just move data, it can also change it and prepare it for analysis. This service is designed to handle complex data projects without you needing to manage the underlying servers, making it a serverless offering that truly simplifies big data tasks for many organizations. This service is fundamentally about creating, scheduling, and managing data workflows. Imagine you have customer information in one system and sales data in another. Azure Data Factory can be set up to automatically pull this data, combine it, and then load it into a data warehouse for your business intelligence team. It supports both ETL, extract, transform, load, and ELT, extract, load, transform patterns. This flexibility is key. It means you can transform data before loading it, or load it first and then use the power of a target compute service like Azure Synapse Analytics to perform transformations. This adaptability is a significant reason for its widespread adoption. So, let's tackle our first common interview question. Question 1. What is Azure Data Factory, ADF? The concise answer is, Azure Data Factory is a cloud-based, fully managed, serverless data integration service. It allows you to create, schedule, and orchestrate data workflows to move and transform data from various sources to various destinations. It's designed for building complex ETL and ELT pipelines. This service isn't just for tech giants. Businesses of all sizes use it. It helps them make sense of their data. It automates processes that would otherwise be very manual and error-prone, which is a huge benefit for any data-driven enterprise today. Using Azure Data Factory offers several significant advantages. One major benefit is its scalability. As your data volume grows, ADF can scale its resources up or down automatically to meet the demand, ensuring your pipelines run efficiently without manual intervention. Another key advantage is its serverless nature. You don't need to provision or manage any underlying infrastructure, which saves time and operational costs. It also boasts broad connectivity, supporting a vast number of connectors to various on-premises and cloud data sources and destinations. This extensive connectivity significantly simplifies the task of integrating disparate data systems, making it a versatile choice for modern data challenges. When you start working with Azure Data Factory, you'll hear about pipelines a lot. So, a common question is, question 2, what is a pipeline in ADF? A pipeline in Azure Data Factory is a logical grouping of activities that together perform a specific task. Think of it as a workflow. For example, a pipeline might ingest data from a source, transform that data, and then load it into a destination. Each step in this workflow is an activity. Grouping these activities into a pipeline allows you to manage and schedule them as a single unit. This organization is crucial for building complex data processes that are both manageable and understandable, especially as projects grow in scale. Next, let's define what makes up these pipelines. Question 3. What are activities in ADF? Activities represent a unit of work or a processing step within a pipeline. Azure Data Factory offers many types of activities. There are data movement activities like the copy activity, which moves data between data stores. There are data transformation activities such as data flows or USQL activities, which change the data's structure or content. And there are control flow activities like for each or if condition, which manage the execution flow within the pipeline. Understanding the different types of activities and when to use them is fundamental to effectively designing your data integration solutions. To make activities useful, they need to know what data they are working with. This brings us to datasets. Question 4. What is a dataset in ADF? A dataset in Azure Data Factory is a named reference or pointer to the data you want to use as an input or output for an activity. It doesn't store the actual data itself. Instead, it contains information about the data's structure, format, and location within a linked service, which defines the connection to the data store. For instance, a dataset might represent a table in an Azure SQL database, a file in Azure Blob Storage, or a folder. Clearly defining datasets is essential for activities to correctly read from sources and write to destinations. These three components, pipelines, activities, and datasets, are the fundamental building blocks of any Azure Data Factory solution. A pipeline orchestrates one or more activities. Each activity performs a specific action, often using datasets to define the data it consumes or produces. For instance, a copy activity, an activity within a pipeline, might take an input dataset, pointing to a source CSV file, and write to an output dataset, pointing to a destination SQL table. Grasping how these elements interrelate is the first major step in mastering ADF and a common focus in technical interviews, as it demonstrates foundational understanding of the service's architecture. One of the most frequently used components in Azure Data Factory is the copy activity. So, a typical interview question is, question 5. Explain the copy activity in ADF. The copy activity is the workhorse for data movement in Azure Data Factory. Its primary function is to copy data from a source data store to a sink, destination data store. It supports a vast array of connectors, allowing you to move data between various systems, whether they are on-premises, in Azure, or in other clouds. You can configure it for schema mapping, data type conversions, and even set performance tuning options like data integration units, DIUs. It's highly versatile and efficient for bulk data transfer operations. While moving data is essential, transforming it is often just as important. This is where data flows come in. Question 6. What are data flows in ADF? Data flows in Azure Data Factory provide a way to build visually designed data transformations at scale. They allow you to create complex data transformation logic without writing any code, using a drag-and-drop interface. Under the hood, data flows execute on scaled-out Apache Spark clusters managed by ADF, so you don't have to worry about managing the Spark infrastructure yourself. They are ideal for tasks like data cleansing, aggregation, joining data from multiple sources, and preparing data for analytics. Their serverless nature makes them powerful and easy to use for complex transformations. Azure Data Factory offers different ways to perform data transformation, and it's important to understand the options. Question 7. What is the difference between mapping data flows and using Power Query in ADF? Mapping data flows are designed for complex, large-scale data transformations using a graphical interface and execute on managed Spark clusters. They offer a rich set of transformations like joins, lookups, aggregations, and pivots. Power Query activities in ADF, on the other hand, leverage the Power Query online experience for data wrangling and preparation. This is great for users already familiar with Power Query in tools like Excel or Power BI. It's generally suited for smaller-scale data prep or when you want to reuse existing Power Query M scripts. Mapping data flows are typically for more heavy-duty ETL. The copy activity and data flows, both mapping and Power Query-based, are central to the practical application of Azure Data Factory. The copy activity handles the extract and load parts of ETL/LT efficiently. Data flows, particularly mapping data flows, handle the transform part with robust, scalable capabilities. Understanding when and how to use each of these is key to building effective data pipelines. For example, you might use a copy activity to stage raw data into Azure Data Lake storage, then use a mapping data flow to cleanse, transform, and enrich that data before loading it into Azure Synapse Analytics for reporting and analysis, all orchestrated within a single ADF pipeline. Automating your data pipelines is a core function of Azure Data Factory. This is where triggers come into play. So, a common question is, question 8, what are triggers in ADF? A trigger in Azure Data Factory is a unit of processing that determines when a pipeline run should be initiated. Essentially, triggers are the mechanism to automate the execution of your pipelines. Instead of manually running a pipeline every time, you can define a trigger to start it based on a schedule, an event, or even a tumbling window of time. This automation is critical for production environments where data needs to be processed regularly and reliably without manual intervention, ensuring timely data availability. Azure Data Factory provides several types of triggers to cater to different automation needs. Question 9. Name different types of triggers in ADF. The main types of triggers are schedule trigger, tumbling window trigger, storage event trigger, and custom event trigger. A schedule trigger runs pipelines on a wall clock schedule like daily at 6 a.m. A tumbling window trigger operates on fixed-size, non-overlapping, contiguous time intervals, useful for processing time-sliced data. A storage event trigger fires when a blob is created or deleted in Azure Storage. Finally, a custom event trigger allows pipelines to respond to events published to Azure Event Grid, offering great flexibility for event-driven architectures. To make pipelines reusable and dynamic, you often need to pass values into them at runtime. This is achieved through parameterization. Question 10. How do you parameterize pipelines in ADF? You can parameterize pipelines by defining parameters at the pipeline level within the ADF Studio. These parameters can then be referenced by activities inside the pipeline, for example, to specify file paths, table names, or filter conditions dynamically. When you manually run a pipeline or when a trigger initiates a run, you can provide values for these parameters. This makes pipelines flexible and reusable across different environments, dev, test, prod, or for processing different datasets without modifying the pipeline definition itself, promoting better development practices. Within your pipelines, you might also need to access certain system information or use temporary values. Question 11. What is the use of system variables and user-defined variables in ADF? System variables are provided by Azure Data Factory and offer contextual information about the current pipeline run. Examples include, these are very useful for logging, auditing, or dynamic configurations. User-defined variables, on the other hand, are created by you within a pipeline using a set variable activity. They allow you to store and manipulate temporary values during the pipeline execution, which can be used for conditional logic, loop counters, or passing state between activities, adding more sophisticated control flow capabilities. Section 5. Connecting the dots integration. Runtimes, linked services, and the Azure ecosystem. For Azure Data Factory to perform any work, it needs compute power. This is provided by integration runtimes. Question 12. What is an integration runtime (IR) in ADF? An integration runtime is the compute infrastructure that Azure Data Factory uses to provide various data integration capabilities across different network environments. It acts as a bridge between activities and linked services. The IR is responsible for dispatching activities, executing data movement like the copy activity, running data flows, and even executing SSIS packages if you are using the Azure SSIS integration runtime. Choosing the right IR type and configuration is crucial for performance, cost, and security of your data pipelines. Azure Data Factory offers different types of integration runtimes to suit various scenarios. Question 13. Explain the different types of integration runtimes. There are three main types: Azure Integration Runtime, Self-Hosted Integration Runtime, and Azure SSIS Integration Runtime. The Azure IR is the default, fully managed compute in Azure used for running activities between cloud data stores and for executing data flows. The self-hosted IR is software you install on an on-premises machine or a virtual machine in a private network. It's used to access data stores in private networks. The Azure SSIS IR is specifically designed to natively execute SQL Server Integration Services (SSIS) packages in a managed Azure environment, facilitating lift and shift of existing SSIS workloads. To connect to any data store or compute service, Azure Data Factory uses an intermediary called a linked service. Question 14. What are linked services in ADF? Linked services in Azure Data Factory are much like connection strings. They define the connection information needed for Data Factory to connect to external resources. These resources can be data stores like Azure Blob Storage, Azure SQL Database, or on-premises SQL Server. Or they can be compute environments like Azure HDI Insight or Azure Databricks. Each linked service contains the necessary details such as server names, credentials, and other connection properties. Datasets then refer to these linked services to access specific data within the connected store. Azure Data Factory plays a vital role in the broader Azure data ecosystem, often working closely with services like Azure Synapse Analytics. Question 15. How does ADF integrate with Azure Synapse Analytics? Azure Data Factory integrates deeply with Azure Synapse Analytics. ADF can be used to orchestrate data ingestion into Synapse SQL pools or data lake storage, which Synapse uses. It can trigger Synapse pipelines, execute Synapse notebooks for Spark jobs, or run SQL scripts against Synapse SQL pools, using dedicated activities. This allows you to build comprehensive end-to-end analytics solutions where ADF handles the data movement and orchestration, and Synapse provides the powerful analytics engine for processing and serving data. This synergy is a common pattern in modern Azure data architectures. Section 6. Keeping an eye on operations monitoring, debugging, and alerting in ADF. Once your pipelines are deployed, you need to know how they are performing. Question 16. How can you monitor ADF pipelines? You can monitor Azure Data Factory pipelines primarily through the Azure portal, specifically within the ADF Studio's Monitor tab. This interface provides a comprehensive view of pipeline runs, activity runs, and trigger runs. You can see statuses, succeeded, failed, in progress, durations, detailed error messages, and input-output parameters. Additionally, ADF integrates with Azure Monitor, allowing you to collect metrics, query logs using Azure Log Analytics, and create custom dashboards for a more centralized and advanced monitoring experience across your Azure resources. Before deploying and even after, you'll encounter issues that need fixing. Question 17. How do you debug a pipeline in Azure Data Factory? Azure Data Factory Studio provides a robust debugging capability. You can trigger a debug run for a pipeline directly from the authoring canvas. This allows you to test your pipeline iteratively with specific parameters. For mapping data flows, you can enable a debug session, which spins up a Spark cluster, allowing you to preview data at each transformation step and inspect the output schema. You can also set breakpoints on activities within a pipeline debug, run to inspect inputs and outputs at specific points, helping to isolate and resolve issues quickly. It's crucial to be notified when things go wrong in production. Question 18. How can you set up alerts for pipeline failures in ADF? You can set up alerts for pipeline failures using Azure Monitor. Azure Data Factory publishes metrics and diagnostic logs to Azure Monitor. You can create alert rules in Azure Monitor based on these metrics, like failed pipeline runs count, or log queries such as searching for specific error messages in ADF logs. When an alert rules condition is met, it can trigger an action group. Action groups can then send notifications via email, SMS, voice call, or trigger other actions like calling a webhook or an Azure function, ensuring prompt attention to critical issues. Effective monitoring, debugging, and alerting are non-negotiable for maintaining reliable data operations. Regularly checking pipeline run statuses, thoroughly debugging before deployment, and setting up proactive alerts for failures can save significant time and prevent data inconsistencies. Common pitfalls include not checking activity-level error messages, not utilizing data previews and data flows during debugging, or having insufficient alerting that leads to silent failures. A well-monitored ADF environment gives you confidence in your data processes and helps ensure that downstream systems receive accurate and timely data, ultimately supporting better business decisions and operational stability in the long run. Section 7. Stepping up advanced ADF features for robust solutions. As your use of Azure Data Factory matures, you'll want to implement more robust development practices. Question 19. How do you implement CI/CD for Azure Data Factory? Continuous integration and continuous deployment. CI/CD for Azure Data Factory is typically implemented using Azure DevOps or GitHub Actions. The process involves configuring your ADF instance with a Git repository, like Azure Repos or GitHub. Developers work on feature branches, and changes are merged into a collaboration branch. When ready for deployment, ADF resources, pipelines, datasets, and so on, are published from the collaboration branch to branch, which generates ARM, Azure Resource Manager templates. These ARM templates can then be deployed to other environments, such as test or production, using release pipelines in Azure DevOps or workflows in GitHub Actions. The primary interface for working with Azure Data Factory is its web-based studio. Question 20. What is Azure Data Factory Studio? Azure Data Factory Studio is the comprehensive browser-based user interface for all your ADF development and management tasks. It provides a visual environment for authoring pipelines by dragging and dropping activities onto a canvas. You can design mapping data flows graphically, configure linked services and datasets, set up triggers, and manage integration runtimes. The studio also includes powerful monitoring and debugging tools, allowing you to view pipeline run history, inspect activity details, and test your pipelines interactively. It's the central hub for developers and data engineers working with ADF. Securing data integration processes is paramount, especially when dealing with private networks. Question 21. Explain Managed Virtual Network, VNet, in Azure Data Factory. Azure Data Factory Managed Virtual Network provides a secure and isolated environment for your data integration activities. When you use an Azure integration runtime within a managed VNet, ADF provisions and manages the network for you. You can then create managed private endpoints to connect securely to Azure PaaS data stores, like Azure SQL Database or Azure Storage, that are also secured behind private endpoints without data traversing the public internet. This enhances security by ensuring that data movement and activity dispatch happen within a controlled network boundary, reducing exposure to public networks. For managing configurations across different environments or promoting reusability, global parameters are very useful. Question 22. What are global parameters in Azure Data Factory? Global parameters in Azure Data Factory are constants that you can define at the data factory level. Once defined, these parameters can be used in any pipeline expression within that data factory. This is particularly useful for managing environment-specific configurations like server names or file paths that differ between dev, test, and prod environments, or for defining values that are frequently used across multiple pipelines. Using global parameters helps to avoid hard-coding values, promotes consistency, and simplifies the deployment process when moving pipelines between different ADF instances, as you can override these global parameters during CI/CD. Section 8. ADF in action, real-world applications and common scenarios. Azure Data Factory is versatile, and a common interview question explores its practical uses. Question 23. Describe a common use case for Azure Data Factory. A very common use case for Azure Data Factory is building ETL or ELT pipelines for a data warehouse or data lakehouse. Imagine a retail company. They might have sales data in a point-of-sale system, customer data in a CRM, inventory data in an ERP, and website clickstream data. ADF can be used to ingest all this data from these disparate sources. It can then transform the data, cleansing it, joining it, aggregating it, using mapping data flows. Finally, ADF loads the prepared data into a central repository like Azure Synapse Analytics or Azure Data Lake Storage for business intelligence, reporting, and advanced analytics. Data migration is another significant area where Azure Data Factory shines. Question 24. How can ADF be used for data migration? Azure Data Factory is an excellent tool for data migration projects. Whether you're moving from on-premises systems to Azure, migrating between different cloud providers, or consolidating databases, the copy activity is key here, supporting a wide range of sources and syncs and offering high-performance data transfer. You can migrate entire databases, specific tables, or even files. ADF allows for schema mapping, data conversion, and can handle large volumes of data efficiently. For more complex migrations involving transformations during transit, data flows can be incorporated. Its orchestration capabilities also help manage the overall migration workflow. A frequent question is about ADF's capabilities with fast-moving data. Question 25. Can ADF handle real-time data processing? Azure Data Factory is primarily designed as a batch orchestration and data integration service. While it can achieve near real-time processing using storage event triggers, which fire when a file lands in storage, or custom event triggers, reacting to Azure Event Grid events, it's not inherently a stream processing engine. For true, low-latency real-time data streaming and processing, services like Azure Stream Analytics, Azure Functions, or Apache Kafka on HD Insight or Databricks are more appropriate. However, ADF can certainly orchestrate these real-time services or process micro-batches triggered by events, fitting into a broader real-time data architecture. Handling data that changes over time is a fundamental ETL task. Question 26. How would you handle incremental data loads in ADF? There are several common techniques to handle incremental data loads in Azure Data Factory. One popular method is using a watermark column, typically a timestamp or an incrementing ID in the source data. The pipeline reads data where the watermark column's value is greater than the last successfully processed value, stored perhaps in a control table. Another approach is change data capture, CDC, if supported by the source system, which directly identifies new, updated, or deleted rows. Tumbling window triggers can also facilitate incremental loads by processing data in fixed time slices, assuming data is partitioned by time. Choosing the right method depends on the source system's capabilities and the data characteristics. Section 9. Mastering the craft best practices and optimization strategies for Azure Data Factory. Building efficient pipelines is crucial for performance and cost. Question 27. What are some performance optimization tips for ADF pipelines? To optimize ADF pipeline performance, consider several factors. For copy activities, adjust data integration units, DIUs, and configure parallel copy settings. For mapping data flows, choose appropriate compute types and core counts for the Spark cluster, optimize data partitioning, and minimize unnecessary transformations or wide schemas. Running activities in parallel where possible instead of sequentially can significantly reduce overall pipeline duration. Also, ensure your integration runtimes are appropriately sized and located, such as Azure IR co-located with data stores, or self-hosted IR with sufficient resources. Regularly review execution details to identify bottlenecks. Security is a non-negotiable aspect of any data platform. Question 28. How do you manage security in Azure Data Factory? Security in Azure Data Factory is managed through multiple layers. Use managed identities for Azure resources to allow ADF to securely access other Azure services without storing credentials in code. For services that don't support managed identities or for on-premises sources, store sensitive credentials securely in Azure Key Vault and have ADF retrieve them at runtime. Implement role-based access control, RBAC, to grant least privilege access to ADF resources themselves. For network security, use managed virtual networks and private endpoints to isolate data traffic. Always encrypt data in transit using HTTPS and at rest. Ensuring your pipelines can be rerun without causing issues is a hallmark of good design. Question 29. What is the importance of idempotency in ADF pipelines? Idempotency in ADF pipelines means that running a pipeline or a specific activity multiple times with the same inputs will produce the same result, without causing duplicate data or other unintended side effects. This is incredibly important for reliability and recovery. If a pipeline fails midway, or if you need to reprocess a specific period due to upstream data corrections, an idempotent design allows you to simply rerun the pipeline without complex cleanup or manual intervention. Designing activities, especially data loading steps, to be idempotent, such as using upsert logic or deleting previous data for a given period, is a critical best practice. Finally, keeping an eye on expenditure is always important. Question 30. How can you manage costs effectively in Azure Data Factory? To manage Azure Data Factory costs effectively, start by monitoring your consumption using Azure Cost Management. Optimize trigger schedules to run pipelines only when necessary. Avoid overly frequent runs if not required. For mapping data flows, use time to live (TTL) settings for debug clusters appropriately, and right-size production clusters. For Azure SSIS integration runtimes, consider pausing them when not in use or using reserved instances for predictable workloads. Regularly delete unused test or development data factory instances and associated resources. Efficient pipeline design, such as minimizing data movement across regions and optimizing transformations, also contributes to lower costs.